There we go. All right, so I'm going to start off just by reading these definitions. So an angle is a figure formed by two rays with the same endpoint. What is a ray again?
Isn't array like the one with the arrow and then wait, an arrow and then a dot at the other side?
Yeah, exactly. So it's a line that has one endpoint. So I'm going to draw an example of a ray right here. It's a ray. Okay, so an angle is formed when you have two rays that have the same endpoint. So they meet at the same point. That common endpoint is the vertex of the angle, and then the rays are the sides of the angle. So this example that I have below, which you can write on the right side of your notebook, I'll just write that down so you remember. We're going to label it, okay? So first, you're going to draw the angle just like you see it, and then we're going to label different parts of it. So the first thing I want to label is the vertex. Who can tell me where the vertex is located or what it's called?
What? Wait, is it K?
Mm-hmm.
K.
That's my vertex. Okay. And then we're going to name the angle. There's two different ways to name an angle. The most important thing when you name an angle, and you can write this down, naming an angle. The vertex, what?
Is that also on the right side?
Yes. The vertex must be in the middle.
This is on the right side?
On the right side, right side. Just write exactly how I have it here. You can do it in your notebook. So draw your picture, label it, and then just next to it, you're going to write this down. The vertex must be in the middle. So here's the two examples for this particular angle. So I can name it angle LKJ, or I can name it angle JKL. But notice, no matter which way I do it, the K is always in the middle because that's the vertex.
I have a question.
Yes.
Why is there a 1 right there next to the K, above the K?
Good question. I believe that's just there because when I took a screenshot of this picture, there were a couple different ones, and then this was just number 1. The other one was number 2, and then number 3, and then number 4.
Oh, okay.
So you can basically ignore that. I erased it. All right, so when you name an angle, you have to give all 3 letters, and they go in the whichever order you prefer as long as the vertex is in the middle. Any questions on that?
No.
Okay. Ready for definitions number 2, or should I let me know if you need a couple more seconds to finish copying.
A couple more seconds.
Okay. Why did I write right side? Just to remind you that this part of it you can write on the right side. You guys stress out too much about left side, right side, left side, right side. Just as long as it's on your notebook and you see it and you can go back and study it, you're good. No stress. Can I go to the next page, or does anyone still need a couple more seconds?
I'm done.
All right. Okay, here we go. All right, so we've got Daniel, I asked you if you were done or not, and you didn't say anything.
I was on mute.
Oh my goodness. One more minute. One more. That's it. You're good? Okay. Here we go. All right. So we've got 4 different types of angles. I want you to copy down basically this chart in your definitions on the left side. All right.
Okay. It's still on
Oh,
the same.
it didn't switch. It's loading. There we go.
Okay, there we go.
Okay. Yeah, so copy down this little chart. Take 3 minutes to do so, and then we'll come back and talk about it.
Miss,
Mm-hmm.
under the angles, are those like the formulas?
Yes, and we'll talk about that. Write them down, and then we'll discuss that when you're done.
All right.
All right. Okay, so we've got 4 different types of angles. You might have seen these words before, but now that we're in high school geometry, we're going to talk about how to name these things and the types of symbols and stuff like Tyrone, why did I say Tyler? That was weird. Tyrone was saying underneath each picture you see like a little equation. We have to understand how to read those things. So, starting with acute angle. Underneath, it's written 0 degrees is less than or equal to, okay, and then this part in the middle, actually, let me highlight everything. I don't know if it comes up. It does. Yay. Okay. So it says 0% is less than, and then you have this over here, M angle A. So it's a little bit confusing because the symbol for angle kind of looks like a less than sign, but it's not a less than sign, it's an angle sign. So that portion, M angle A, in words, this says the measure of angle A.
I think this is the lesson I understand the most.
Good. So if we're looking at that inequality, can somebody try to put that into words? What does this all mean? 0 degrees is less than, measure of angle A is less than 90 degrees.
Maybe it's talking about like the angle size, like how
Mhm.
open or closed it is.
And what does the 0 degrees and the 90 degrees tell you?
Ooh, I don't know about that one. Somebody
Someone
else.
else can jump in.
Like I think Tyrone already said this. I think I'm just gonna repeat what he said, but I think it's like how like big it is. I don't know. Like
So it is telling you how big it is. That's correct. So the angle measurement is kind of like if you have a mouth, right? It's opening and closing. So the angle measurement tells you how big or small that angle opens or closes. But what I'm asking is, in this sentence underneath the picture, what does it mean by saying that 0 degrees is less than the measure of angle A is less than 90 degrees? So what does this whole thing mean in real words?
Wait, I'm still writing the other ones. So they all have a symbol
Mm-hmm.
at the end, and they all have a number.
Mm-hmm.
So, maybe
Don't stress about the symbol or the number. I just want to know what this inequality is saying in real words. What is it saying?
the degree of the angle,
Is what?
it's
90
between
degrees.
0 degrees and 90 degrees.
Say that again, Perla.
That the measure of angle A is between 0 degrees and 90 degrees.
There you go. You got it. Okay. So again, the inequality is a mathematical way of saying something. It's just writing it in math instead of putting it into words. And what those words are saying is that the measure of angle A is between 0 degrees and 90 degrees. Those inequalities, it's literally showing you how the measure of angle A is in between those two numbers. So an acute angle is any angle that is between 0 and 90 degrees. Any questions on that?
Oh, okay, that makes sense now.
There you go. And for all of them, we're looking at the same exact thing. So for a right angle is when the measure of the angle equals 90 degrees. It has to be exactly 90 degrees. So this one right here, we know that one's 90 degrees. What about an obtuse angle? What is that one telling you?
Wait, why does it say 90?
The obtuse angle,
Mm-hmm.
that the measure of the angle is between 90 and 180 degrees.
And there you go. So the
And for the
measure,
straight,
the measure of the angle, so this angle over here for obtuse is bigger than 90 degrees. If I drew an imaginary 90-degree angle on top of it, you would see if this is 90 degrees, right? Then angle A is bigger than that. So an obtuse angle is greater than 90 degrees, but less than 180 degrees.
And for the straight angle, the measurement of the angle is equal to 180 degrees.
Exactly, is equal to. So this whole thing is 180 degrees.
Okay, I got it.
Cool? Any questions on acute, right, obtuse, or straight angles?
Nope.
All right. I'm going to go ahead and go to the next page. All right. Last definition, you're going to copy only the parts that I highlight. Oops. Okay. An angle bisector is a ray that divides an angle into two angles that both have the same measure. Just that.
And do we write that angle on the right page?
Correct, yeah. Oops.
Miss, today at the beginning you didn't put music on.
You know what? I did, and I forgot to share my computer sound, so I was listening to it.
Oh.
But I just noticed that you were not listening to it. My bad. And it was good music too. I was like, it's Friday. I'm going to play some good jams.
Is this all still review?
No, this is new stuff. We're going to review at the end. Okay. Let's go ahead and understand what this is all saying. So remember, a bisector, like we said before, a bisector cuts something in half. So an angle bisector simply cuts an angle in half. That's all it's doing. So let's take a look at this figure over here. So I have a sentence, and that sentence has a lot of these sort of mathematical geometry symbols and we have to get used to learning how to read those symbols. So I'm going to say that sentence, and I'm going to say the words that those symbols are representing. So pay close attention. In the figure, ray BD bisects angle ABC. So the measurement of angle ABC equals the measure of angle CBD. Notice what I did with all that? How did I know that it was a ray BD? How did I know that?
Because if you don't look at C and A, it's just a straight line going this way. Like,
Yeah, but just from when I was reading that sentence, look at the sentence. What's
oh,
in there?
because it has an arrow over it.
It has an arrow over it. So I know that this is saying ray BD. And I know it's not writing. Give me a moment. Don't know why it's like this. Okay. Then how did I know that I was going to say angle ABC?
Because it has an angle in front of it.
It has that angle symbol. How did I know that the other two were saying measure of angle ABC?
It has an M. That
Yeah.
stands for measure.
Exactly. So all I'm doing is I see what I see on the page and I can translate that into actual English. So I'm just gonna like label all of this. This is measure. Okay. All right, so this is telling me that BD, so I'm gonna actually color code everything. So our ray, BD, is bisecting ABC. So this whole bigger angle, ABC, is being bisected, so it's cut in half by that ray. Okay, so then it's also saying that angle ABD, so where's angle ABD? Someone give me a color to code it with. What color should I use?
Pink.
Pink? Okay. So this angle over here, the pink one, is equal to, I'm gonna use yellow, this yellow one. So I'm gonna write that down. So the measure of angle ABD is equal to the measure of angle CBD. Okay, I know that was a lot of words, a lot of definitions, so I want to know if you guys have any questions about this. Questions going once?
No.
Questions going twice? All right. The last thing I want to show is how these little arcs, so I highlighted the one that I highlighted in pink and then the one that I highlighted in orange. It was yellow before, but I changed it to orange because that shows up better. Those little arcs in the picture tell me, without using words, they tell me that those angles are equal. So when you see arcs, that's going to show you that something is equal. Does anybody remember how to show that something is equal when it's a line segment? We covered that last class. So
What's the question again?
if I had these two lines like here, and I want to show you that they're equal, how do I do that with a diagram? So in the angle, I could show those little arcs, but on lines, what do I put on them to show that they're equal?
A square. Wait. A dot?
Not a dot.
Is it those little lines?
Yeah, little ticks.
all those.
So if you see a little tick mark like that, it's showing you that those two lines are equal. On an angle, the little arc is what shows you that the two angles are equal. Okay, next slide. Okay, here's your last definition, but before you write it down, I want to break it down. Okay? Can I have a volunteer read it out loud for us?
Me.
Go for it. Go ahead.
Postulate angle addition postulate. If S is in the interior of angle PQR, then the measure of angle PQR is equal to the measure of angle PQS plus the measure of angle SQR.
Awesome. Nice job reading all those symbols. Love that.
Thank
you. Okay, so again, before you write this down, I just want you to pay attention to the screen, and then I'm going to break it down first. All right. So the angle addition postulate is just simply telling me that if S, so notice the dot S, is in the interior of angle PQR. So P to Q to R, that's this long, the obtuse angle. Okay, so, oh, and it's not highlighting it again.
This is a definition?
Oh my goodness. Yes, it goes under definitions. As it says on the top. It says definitions on the top. Therefore, it is a definition.
Just making sure.
Okay. All right, so if S is in the middle, just like it is here, then all this is saying is that the two angles it forms, when you cut it, when you add them together, it's going to equal the larger angle. So one more time, I'm going to show that with colors. So when I cut that larger angle in half, I get two smaller angles, right? Those two smaller angles, when you add them together, it's going to equal the large angle that they came from. Okay? Does that sound a little like it makes more sense? Man, I have radio silence from this class today. Okay.
Wait, so we're just adding what's the names? I forgot.
Say that again?
So are we just like adding what's the names to I forgot. What are they called again?
Angles?
Yeah.
Yeah, you would add them together. So we'll do an example of that in just a second. So for now, write down the definition. Even if it doesn't make total sense to you, write it down. And then in the next example, you'll see it's actually not that hard. But like I've been saying, geometry likes to make it look hard, even though it's not actually hard.
2 seconds later, Ms. Lopez says, this might be a little difficult.
All right, finish up writing that definition. Who needs one more minute? Okay. Okay, awesome. So let's see an actual example because it's a lot easier to understand the postulates when you see an actual example. All right, so here I have a picture of this is what's called, does anybody actually know what this tool is called that kind of looks like a circular ruler?
A protractor?
Yeah, it's a protractor. And if we were in real life, I would have you guys actually use a protractor to measure these out, but obviously we're
Why are we
not.
doing fourth grade work?
This is not, trust me, it's not fourth grade work. It's gonna get harder. Okay, just don't complain about it, Jalen. I could make it harder if I wanted to.
You said it looks hard, but it's not hard at all.
Not yet. All right, use the angle addition postulate to find the measure of each angle. All right, so I'm gonna start with angle BXC. So I'm gonna highlight it. Okay, and you do not have to write this right now because right now I want you guys to look at the screen and see if you can figure out how this all works. How do you measure this? So when you're measuring on a protractor, you have to find the difference in the numbers that you see. But there's two different sets of numbers, right? Do you see how there's the larger numbers on the bottom portion and then there's smaller numbers on the top portion? So I see 40, 50, 60, 70, and then I also see 140, 130, 120, 110. So when you're measuring, the first thing you're going to think is this an acute angle or an obtuse angle?
Acute?
It's
Okay.
acute, exactly. So are we going to use the bigger numbers or the smaller numbers?
The smaller numbers.
Okay, good. All right, so let's go ahead and count. So I see that it passes through 40 on the left side, and then it passes through 70 on the right side. So what's the measurement in between?
In between 50 and 60.
How much
Wait.
between 40 and 70? How much is that?
30.
30. So this is a 30-degree angle.
Oh,
So the measure of angle BXC equals 30 degrees. Oops.
how a protractor.
Good. All right, now we're going to look at BXE. So BXE starts off at the same place, but now it's going all the way over to here. So is this purple one an acute angle or an obtuse angle?
Obtuse.
Obtuse, okay.
Obtuse,
So what I'm gonna do is instead of measuring from the 40 to the 150, I wanna see, because this is at 150 down here, in case you can't see that number, that's 150. I wanna see how much is this angle right here, CXE. So take a look, go from C to E and count, do the math. How much is that?
180. I mean 80.
80, exactly. So if this is 30, if the other one was 30 and then this one is 80, how big is the largest angle? You have to add them together. So the measure of angle BXE is going to be 30 plus 80. So it's going to be, oh, I see Perla put it in the chat. 110
110.
degrees, exactly. All right, so like I said, the postulate, when you write it down, it kind of looks confusing because it's got all those symbols and stuff. But really, it's just telling you can add two angles together and make one big angle. Any questions on that?
I have one question.
Okay, what is it?
I kind of need help on the part where, like, you see where you got the 30 degrees angle and the 80. How did you get those again?
Because it's passing through 150 on the right side, and it's passing through 70 on the left side. So I just subtracted. What's 150 minus 70?
That's like 30 or 80.
That's where I got 80.
Oh, okay.
Okay.
And you got 30 from subtracting 70 minus 40.
Yeah.
All right.
Okay, so now here's what you can write down. So these are going to be, I'll show you how many there are. We have 1, 2, 3, 4 practice problems. We're going to do those now together. All of this goes in the right side of your notebook. So I know it's going to take a minute to write things down, guys, but I need you to be as speedy as possible because we don't want to take up too much time just writing.
Ms. Lopez, what is that arrow pointing at? The 72 degrees, the Q, or
Other,
the angle?
the angle. So this is corresponding to this angle right here.
Okay.
Mm-hmm. All right, finish up writing. And we'll go over it in just a second. So we need to find the value of x, which is algebra, isn't it? Interesting. Okay, we need to find the value of x given that the measure of angle PQS is 112 degrees. So where's PQS? I'm going to look, and I see PQS is the large angle. It's the obtuse one. Okay, so I know that measure of angle PQS is 112 degrees, and I need to find the measure of the acute angle inside of there, where it says 10x. So what can I do? What do you guys think? Given what we know about the angle bisector and the angle addition postulate, what can I do? No one? Crickets?
Wait, can you repeat the question?
Sure. I need to find the answer. I need to know what x is equal to. And I have some rules that I just learned. We just learned some rules. Can somebody summarize what we learned about angles and the addition postulate?
Well, Why is the class so dead?
I don't know, but y'all are really making my Friday a little boring today. I've got 2 people, sometimes 3 people participating, and everyone else, I don't know, you're just ghosts.
Mm-hmm.
Because I could teach this class, like I can just do it all myself and you guys figure it out. So I'm trying to give you guys the opportunity to participate, but if you don't want to take it, we don't have to do all that. Okay, all right, it is what it is. So my angle addition postulate. Which we just talked about, okay? This is not like I'm making this up out of thin air. We literally just talked about this. The angle addition postulate tells me that I can add 2 angles and make a bigger angle. That's it. How many angles do we have here? We have 2 smaller angles and they're making 1 bigger angle. So I can use my angle addition postulate to figure out the measurement of that one we don't know. So I know that because of the angle addition postulate, I know that the measure of angle PQR plus the measure of angle RQS is going to equal the measure of angle PQS. The 2 smaller angles add up to the bigger angle. So now I'm going to fill in what I know. PQR is given to me. They already tell me PQR is 72 degrees. So I know this is 72 degrees. RQS is also given to me. That one is right here. They tell us that this angle in here is 10x. And we also know the measure of angle PQS. They give it to us in the very beginning in the problem. That's 112 degrees. So I know everything except for x. I know algebra, right? We all know algebra, so we can solve for x. I'm going to rewrite this problem without all of the degree symbols just because you do not need to have them in order to solve the question. We'll add it at the end. So now I'm just solving for x. I'm going to subtract 72 from both sides.
Doesn't the degree symbol just mean it's an angle and nothing else?
Yeah, that's all it means.
All right.
I'm going to be left with 10x equals
4. X equals
112.
4.
Thank you for your answer, Jalen, but I would much rather appreciate if you participate in between now and when I get the answer, not just yell out the answer to the whole class.
Oh, my bad. I'm sorry.
8, 9, 10. Okay, so this is 40. 10x equals 40, and it's loading slowly. I divide by 10 on both sides, and I get x equals 4, like Jalen said. 4 degrees. So algebra is not going away. Algebra is very much here to stay, and we're going to use it in our geometry classes very often. So that is something that you'll see again and again. Do I have any questions?
No.
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 All right. Take 30 more seconds to finish writing it down, and I'll move on to the next question. All right. If you still need to write something down, you're just going to have to watch this video later because I'm moving on. Okay, we have similar idea here. I'm looking for the value of y. And that it tells me a bunch of information. All of this is very, very important. we're going to set this up the same exact way. We know that the angle addition theorem, postulate, tells us that we can add the two smaller angles to get the measure of the big angle. So I'm going to set up my equation. I know that the measure of angle KLN
47.
is 47. And then I'm going to add that to the measure of angle MLN, and that's going to equal the measure of angle KLM. So the two smaller ones equals the big one. Like Tyrone said, KLN, that's this one right here, 47. So I know 47 degrees. I'm not gonna write the degrees because I don't need it until the end. So 47 plus the other small one, 16y, equals, what's the biggest one measure?
135. Yay.
135. Take 2 minutes. You're gonna solve for y. Put your answer privately in the chat when you get it.
Okay.
All right, gonna go through it. The answer is a decimal, yes. And for the purposes of of geometry, I know in algebra a lot of times when you got your final answer, I told you to leave it as a fraction. With geometry, since we're measuring things, we have actual measurements, it's better to leave it as a decimal. So I see lots of correct answers in the chat.
So when doing like angles, you try and leave it as a decimal? Okay.
Just because that's easier for measurement. Okay. All right, so yes, my final answer is 5.5. Would anyone like for me to go over how I got that?
Very yes, please.
Yes, okay. I'm gonna subtract 47 from both sides. This is a simple equation, guys, 2 steps. Subtract 47 from both sides, I have 16y, and then 135 minus 47 gives me 88, and then I divide by 16.
Okay, I got it.
5.5 degrees. Any other questions?
No.
Well,
All right, this one you do not need to write all down because it's a lot. We're just gonna go through each of these letters together. So we're gonna determine whether each of the following pairs of angles have equal measures. So we wanna know if these are equal. So we're gonna start off with KJL. So I'm gonna highlight that. KJL. L. Okay. And LJM. So LJM. So the green one and the orange one. And we want to know if those are equal. We are not given any information other than the diagram. So you have to look at the diagram very carefully, and I'm going to erase it just for a second, because what do you guys see in that diagram that's going to tell us something very important?
Is it the numbers?
There's one number that we're going to pay attention to, but what else do you see?
I don't.
The lines in the middle, they're not all even.
They're not all even. How can you tell? I want to know more specifically, what symbols do you see that tell you this?
Wait, there's like some are like right angles, some are like
Where do you see a
curves
right angle?
at M and K.
MJK.
MJK. Thank you for naming it correctly, Perla. MJK, right here. Okay, well, what two angles are we looking at again for letter A? We're looking at KJL and LJM. Where are those located? Are they inside the right angle or outside the right angle?
Inside.
They're both inside of that right angle. So I have KJL, which is just the right side of that, so this part right here. And then I have LJM, which is the other half of that. This one right here. So are those two equal? Well, I know that the orange one, LJK, is 42 degrees. And if that one is 42 degrees, how much is the other one going to be, the green one?
48.
Good. How'd you get that?
Because they're inside the right angle and the right angle is 90 degrees.
Precisely. So we know that those two have to add up to 90 degrees because it's a right angle. So therefore, these two are not equal. All I knew was that I had a right angle and that one of those was 42 degrees. You had to figure out the rest of it just by looking at the diagram. And you're going to see a lot of questions like this in geometry. It's all using your eyes and your knowledge. Any questions on A?
I'm still kind of confused on the 48 part.
The whole angle has to add up to 90 degrees because you see that right angle symbol, right? That it gives you the right angle. It shows you that this is a right angle. So if part of that is 42 degrees, the other part has to add up to 90. What's 42 plus 8 plus 48?
42 plus 48 is like 60. Wait. 90.
Okay, there you go.
Okay, I got it.
All right, letter B. We want to see if MJP is equal to PJR. So let's look for them. MJP and PJR. Let me erase everything else. Okay. So we have MJP, which I kind of messed up. Okay. MJP, and then we have PJR. So take a look, see for yourself, see if you can figure this one out first without me, and then we'll talk about it. All right, couple more seconds. Okay. So first I want to see a vote. So using in the participants button, or the participants, yeah, click on participants, and then there's the yes and the no buttons. Okay. So click on whichever one you choose. Are they equal? Yes or no? I have 1 vote. 2 votes.
Miss, I'm not sure.
Just pick an answer. It doesn't matter if you get it wrong. Okay. Mostly yeses. And there was a no at one point, but it went away. All right, let's find out. I'm going to erase the colors just so we can see the diagram a little more clearly. Okay, starting with PJR, the blue one. PJR. What do we know about that measurement? How much does PJR measure? How many degrees?
94.
Good, 90, yeah, 94. How'd you get that?
I added them.
Yeah, you just add. So we know that this one is 94 degrees. Okay. It's loading slowly for me. Give me 1 sec. Okay, there we go. So we know that measure of angle PJR is 94 degrees. All right. Then we have MJP. That one's a little harder, right? Because we know we have 46 degrees, but there's no label for the other part of that angle. So can
Is
anybody,
the other angle like 40?
where are you getting 40?
I added all of them and they got me 140, and I think this is like a straight or a straight line or
Mhm.
whatever. So it would be 180 degrees. So then I fill in the blanks, and 140 plus 40 is 180 degrees.
Okay, so I see what you were doing. The only thing is that, does it say anywhere on here that that is a straight line?
No.
Wait,
It
it
does.
looks more like a obtuse angle.
Yeah, it looks straight, but I don't know. It's kind of hard to tell. It might be a little bit crooked.
Which one, Miss?
PJ, this long one,
Yeah,
PJK,
that's crooked,
right?
definitely.
It's a little crooked. So we can't guarantee that this is 180 degrees because we can't guarantee that it's a straight line. However, look at the symbols. What symbols? So we know that we have a right angle symbol over here, but what other symbols do you see?
An obtuse symbol?
There's no
Wait,
such thing as an obtuse symbol.
wait.
Describe it. What do you see?
We can see that it's bigger than 90 degrees.
Okay, you could see that it's bigger than 90 degrees, but again, we don't know that for sure, because we can't guarantee that. It doesn't tell us that. There's only one more thing that this diagram is telling me, and it's using symbols to show it. So look for the symbols. What do you see inside of that diagram? There's numbers, there's the right angle symbol. What else? No? Okay. Do you guys see? It's not showing up yet, but it'll show up in a second. Okay, the missing angle, the one we don't know yet, we know 46, we know 48, we know the other 46, and then there's one blank. What's What does that blank have there? What do you see?
An acute angle or
It is an acute angle. You see that little line? The little
Mhm.
slash? Okay. Remember what I just said. If you see that and you see it in two places, it means those two things are equal. So where else do you see that little slash?
and P and Q,
P, J,
PQ,
Q.
PJQ.
So what does that tell me about my unknown angle? How much does that actually measure?
48.
I think I heard it, but say it again.
48.
48 degrees. Those two angles are equal because it's showing us by giving us that little symbol in the picture, it's showing us that they're equal. So I'm going to label it once this loads. So I also know this one is 48 degrees. This is the little symbol right there. That little symbol
Oh,
is
that.
there for a
I
reason.
thought it had to be completely straight in order for it to count. Oh,
No.
I get it now. As long as it's a slash, then it counts.
A slash,
Okay.
exactly. Or a little arc. Okay. So we have 46 and 48, and then we also have 46 and 48. Therefore, these two angles are equal. Next one. LJP. Erase everything else. LJP and NJR. Okay. That's L, J, P. And then NJR. N, J, R. Okay, let's figure this one out together because we're running out of time. Let's fill in the blanks that we know.
Isn't the LJP 148 since we already figured it
Yeah.
out for this one?
I feel like D is correct.
Okay, you think they are?
Yes.
Okay, but we have to make sure. So I'm going to fill in all my blanks. We just found out that this one is also 48 degrees. And from last time, we also had the other blank filled in. How much was that one?
48 too, I think.
Was it also 48? Yeah. Okay, so LJP, my orange one, that's 48 plus 48 plus 46. And then my blue one is also 48 plus 48 plus 46. So yes, Daniel was correct.
Yeah, it's 142.
These are the same. Okay, moving right along, let's finish this out. We have NJK and PJR. So that's MJK, which we already know something about, right? That came up earlier. And then we have PJR. So that's PJR. Alrighty. What do we know about MJK? The red one.
That it's 90 degrees.
Yeah, we know this one's 90. So we know this whole thing is 90. And then we can do the math for PJR because we already have that filled in. How much is this one?
94 degrees.
94 degrees. So these two are not equal. All right, last one. I want you to do that last one on your own.
Wait, can you draw the line?
Do you want me to color code it?
Yeah.
Okay.
It helps me understand it better.
Yeah, me too. I got you. Okay, so KJR and MJP. Alrighty. So when I'm looking at this diagram, I notice that there's only one angle missing out of all of it. Does anyone have any idea how I can figure out what that angle measurement is?
Maybe from another angle.
Wait, I think you can figure out just by adding up all the angles and then see if you
Yeah.
reach up to like 300, 360, right?
Yeah,
360.
360. Good, you got it. All of these angles need to add up to 360 because if you add them all up together, that's a circle, and a circle is 360. Nice job, Jalen. So that's exactly what you're good. So did anyone do that? If you add everything up?
I'm doing it now.
Okay.
Mm, um, okay, so 46%. I don't think it equals 360.
I'm gonna get a calculator. I don't have time for this.
I don't
Come
think
on
it's
now.
360.
Well, it's not going to equal 360 because it's missing a slice. So we're trying to figure out how much is that missing slice.
Okay, so is it 36 degrees?
It's 82 degrees.
Wait,
82?
Yeah, you guys take too long. Just add 48, 48, 46, 46. The other 48, 42.
So are these the same or no?
No.
let me add all of them now.
We don't have time. We don't have time. Okay. So we are out of time right now. I know I tried to promise you guys to finish by 1:45, but we are out of time. We didn't get to review because y'all, I said this last time, it's disappointing for me when the class moves really slowly because you guys just sit there quietly without actually participating. And that's what happens at the end of the day. That's what happens. So that's up to you. That's not up to me. You guys have to find it within yourselves to be a little more participatory because this is a small class. So you can't just sit here quietly and hope everybody else does the work for you.
I try.
So, okay, we didn't get to review, unfortunately. However, if you would like to review before you take your quiz today, you can do so by watching the videos that I've already posted up on Teams and on the YouTube channel. The quiz will be, I'm going to post the quiz to Microsoft Teams as soon as I log out of Zoom. So it will come up on your Teams page and you have until midnight to finish it. Do I have any questions?
How long is the test?
4 questions.
Oh, just like what's the name? Last year?
Yeah, there are always going to be just 4 questions every Friday. Usually I'll have you guys do it during class, but since this took too long, we didn't have time to do it during class. The only other thing that I'm changing compared to last year is when you finish your quiz, you need to take a picture of your work. So you have to be writing on in your notebook while you're working on the quiz. Take a picture of that and send it to me on Remind or to my Google phone number.
So that you know we did the work.
So that I know you didn't just look it up on PhotoMath.
All right, that makes sense.
Any last questions?
No.
Okay, so look for that link, look for the assignment to come up on Teams. I'll do it in the next 5 minutes. Good luck on the quiz. It is due at midnight. And what else is due at midnight tonight?
Khan Academy?
Khan Academy.
Oh, I already did mine.
Good. Good if you already did it. All right, have a good weekend, everyone. Good luck on your quizzes.
Bye, Miss
All right.
Lopez.
Bye.